Okay, so today we're going to talk about significant figures in calculations. We're going to continue on from our last video where I was going over the basic rules of how to write significant figures. Alright, so first things first, rounding rules from math apply. So let's write that down. I mean, you should all know this, but just in case anybody needs a review. Rounding rules apply. So what that means is if number, or actually, if the last number, and it's the last number dropped, is greater than 5, you round up. If the last number dropped is less than 5, round down. Super simple. Alright. And then another ground rule we need is for multi-step calculations. Alright, so for multi-step calculations, do not round intermediate steps. That is super, super important because you could get a wrong answer. So you're only going to round the final answer. Okay. So for addition subtraction, your answer should have the same amount of decimal places as the number with the fewest decimal places. So it should have the same amount of decimal places as the number with the fewest decimal places. Okay, so let's do two quick examples about this. I'll do one with rounding up, one with rounding down. So we have 1.0 plus 3.02. So addition, subtraction. And this goes like if you have a multi-calculation problem, say you had a multiplication overall and you had like a few numbers being added or subtracted in parentheses. That's still a multiplication problem, but you still have to apply the addition and subtraction rules to figure out how many significant figures that specific part has. And I have an example later where this, happens, and we're going to go over it. Because you'll get the wrong answer if you don't do that. And I know this all might seem silly, but the whole point of this is to have a standard way of rounding information so that when people publish, scientific publications, journal articles, whatever, all the data can be replicated with ease in terms of calculating, because you don't want significant variances in numbers when you're talking about super, super small decimals, or even big ones. Like a tenth or a hundredth can be a big deal in chemistry or in physics or any sort of scientific discipline. So that's why this is important. Anyway, sorry for the sidebar, but we have 1.0, which that's an explicit point, so that's one decimal point. And this is 1, 2. So to find out how many we need to find out what the answer is first. So clearly it's 4.02. We only need one decimal point though. So this is the number we're going to be rounding from, is this 2. Clearly it's less than 5. So our final answer is going to be 4.0. Super, super simple. I'm going to give you one that's a little bit more challenging. I know it's different than the PDF I posted online, but I wanted to show you, rounding up, I guess. So 1.435. So when, let's do, it's 3.8, so 3.875. So 3.875. Oh, and that just reminds me, this is greater than or equal to, so make a note of that. Not just greater than. I messed up there. 2.44 plus this equals 3.875. You have 2 decimal places there, you have 3 there. So that means we have 2 that we need there. We're rounding up with this one. That's the one that's getting dropped. So our answer is actually going to be 3.88. And that would be the correct final answer. Alright, so addition, subtraction, super easy. It's all based on the number with the least amount of decimal places. Now, multiplication, division. This one's a little trickier. It's not too difficult though. Let's write this down first. Alright, your answer will have the same amount of significant figures as the number with the fewest amount of significant figures. Sorry, it's hard for me to talk and write at the same time. Okay, so I'm going to give you a pretty easy example. So we have 3.1 over 2 times 2.72 over 3 times 5.443 over 4. So just so you know that in this one, I don't care about the denominator so much because we can always factor that out. So we're going to focus on the numerator for significant figures because if we divide all these, it's going to be a hot mess. So right now, this one has 2, that has 3, and this has 4. It's super simple because there's no zeros. And the reason I'm saying that you can kind of ignore that is you just 2 times 3 is 6, times 4 is 24, so 1 over 24 times 3.1 times 2.72 times 5.443 is exactly the same thing. And in my opinion, this looks better, or you could just divide it by 24. It doesn't matter. If you get in the habit of doing stuff like this, it makes math easier. So anyways, that means that our answer needs to have 2 significant figures. So let me pull up the calculator and we're going to plug this in. I'm going to just put all this over 24. It's the same thing. What is going on with this? Alright. So we have 3.1 times 2.72 times 5.443 divided by 24. And then our answer is 1.912, some super long decimal, but we only need two significant figures. So I'm going to just put 1.91 because the number that we're actually going to be dropping is the third number. So because it's less than 5, that means our answer is going to be, it's going to round down and it's going to be 1.9. And that's how you would do something like that. I have another one on the PDF where it's literally the same thing. I'm not going to go over it on the video. This is plenty practice enough. I'm going to go over some multi-step calculations. because those are things that I think, they're going to come up frequently. So you need to know how to, deal with those. So let me copy this down and we're going to go over it. So, all right, so we have 6.78 times 5.903 times 5.489 minus 5.01. Okay, so one thing I want to make a note of. I want you to try this on your own, but I'm going to give you a hint. You still have to apply the addition subtraction rules to inside the parentheses in terms of significant figures. Do not round it though. So anyway, sorry about that. We have 6.78 times 5.903 times whatever this is. So that's going to be 0.479 because you just cancel that out. You could do it right here if you want to see. So that's gone, 479. So 0.479. Now, the thing you need to be aware of, there's 2 decimal places and 3. Remember, addition, subtraction. So you need to go off the number of decimal places. So that means only those 2 are significant. So your answer should have 2 significant figures. Do not round until the very end. I know this is a little confusing, but it's just, once you're familiar with the rules, these are super easy to do. Alright, so you have 6.78 times 5.903 times 0.479. So it comes out to 19.17. But, we only need 2 significant figures. So let's just put 1.91. This is the number we're dropping. It's less than 5. So our answer is going to be 19. I know that's a little confusing the first time you do it, so I'm going to give you another one to do. So we're going to do, let's see. I'll do one where it's addition, subtraction, and then we'll call it good. Alright. So we have So we have 19.667 minus 5.4 times 0.916. Excuse me. So, interesting. That has 2 significant figures. That has 3. So you have to apply the multiplication division significant figure rules inside the parentheses. Overall, we're going to be applying the addition subtraction to our final answer. But we need to know what we're working with in here in terms of rounding. So let's do that in the calculator because I can't do that in my head. So 5.4 times 0.916. So that's 4.9464. We only need 2 significant figures. So 1, 2. So that means we're going to be rounding the 4 off. So it's going to round down, and we're really just working with these 2. It doesn't even matter. You're going to put the whole thing in the calculator, though. So remember, this is addition, subtraction. We're technically only working with 1 decimal place. This one has 3. So that means that our answer should have 1 decimal place. So let's plug this in the calculator and we'll see what we get. 19.667. And another cool thing you can do is, even with the scientific, you can, instead of retyping this, usually there's an option like second answer, and you'll get the same thing. It'll just plug the answer in instead of you having to retype it, like if you have a long decimal place. But we're going to end up with 14.72. We need 1 decimal place, so let's write down those. And let me change that to black. So that means that that's the decimal place we're looking for. That's what's getting dropped off. So it's less than 5. Our answer is 14.7. And that's really how you do these problems. I'm going to stop the video here. If you have any questions, please reach out to me. You can fill out a comment on the website, or if you're one of my students, email me on Canvas, because I'm going to obviously get back to you sooner on that. So, and if you have any questions on any of this, please ask, and I'll see you in the next video.